Hello again, 8th graders. This is Chapter 4.8b, Real Numbers. The definition for real numbers is the set of numbers made up of the rational and irrational numbers. Now the truth is, in math, you have worked with different sets of numbers all along. When you were probably back in 4K, 5K, first grade, second grade, you started to work with counting numbers. And we called them whole numbers, like 0, 1, 2, 3, 4, etc. Then when you got to about 6th grade, we started telling you about integers, which were the negative numbers. Negative whole numbers like -2, -5, -10. When you were starting in about 4th grade or so, we did talk to you about fractions. What they probably never told you is that fractions are really rational numbers. Well, now you're in 8th grade, so before you get up to high school, we're going to be telling you that there are sets of numbers that you need to be aware of. One are the rational numbers, the other ones are the irrational numbers. By definition, a rational number can be written as a over b, that's your fraction idea, where b does not equal 0, because that would be undefined, and a and b are going to be integers, so you can't have something like pi, for example, in a rational number. What are some examples of irrational numbers? Well, here you go. Fractions. Things like 1/2, 3/2, -5/6, 8/8. Again, notice they're integers, and the bottom numbers, the denominators, cannot be 0. Another example of a rational number is an integer, like 0, -3, +3. Terminating decimals, such as 0.3, 0.5, 1.875. Also, your repeating decimals. 0.3 repeating, -0.6 repeating, .12 with a repeat bar, and then something like -0.8, and then just the 3 repeating. Mixed numbers, -2.5, 1 and 1/2, 4 and 7/8. Irrational numbers cannot be written as a over b, and they will include things like non-terminating, non-repeating decimals, such as 0.2022, 0.222, 0.2222, square roots of numbers that are not your perfect squares, such as the square root of 2, the square root of 3, the square root of 56, and pi. Pi is considered an irrational number. One of the main things you're going to be doing is identifying a number as rational or irrational, and then you're going to have to explain. And we explain by using any of the explanations, reasons, examples of things that we had on the prior page. So if we look at 0.81811, 8111, this is going to be irrational. And my reasoning is that it's a non-terminating non-repeating decimal. If I look at B, -0.81, where the 81 repeats, well, that's going to be rational. And it's going to be rational because it's a repeating decimal. Okay, you hit pause and do the next couple. Actually, I would suggest you do C, D, E, and F, and then I'll go over them. Okay, C is going to be rational for the very reason that it is a mixed number. D is going to be irrational. It's a slightly longer explanation. It is the square root of a number that is not a perfect square. E is going to be rational. It is the square root of a perfect square. You could give an alternate explanation that it's an integer. Square root of 81 is -9 or 9, which are integers. And that could be an alternate explanation. And then our last one is also going to be a rational number. And it is a terminating decimal. The next page gives you kind of a graphic organizer of what are real numbers. We have rational numbers that include integers, fractions, and mixed numbers, terminating and repeating decimals, square roots of perfect squares. The irrationals are the non-repeating, non-terminating decimal, pi, and square roots of numbers that are not perfect squares. And that concludes lesson 4.8b.